Hello dear aspirants, welcome to Epitome IAS. So we are doing the UPSC PYQ analysis and today's topic would be climatology from the geography. So the first question is, with reference to the Earth's atmosphere, which one of the following statements is correct? Option A, the total amount of insolation received at the equator is roughly about 10 times of that received at the poles. Option B, infrared rays constitute roughly two-thirds of the insolation. Option C, infrared waves are largely absorbed by water vapor that is concentrated in the lower atmosphere. Option D, infrared waves are part of visible spectrum of electromagnetic waves of solar radiation. So if you see here, the first statement says that the total amount of insolation received at the equator is 10 times more than the amount of insolation received at the poles. So if you see this picture, you will understand. Let us say this is the position of the sun. So the direct rays of the sun falls on the equator region. Let's say this is the equatorial region. So the direct sun rays falls in this particular region, and the rays which are falling in the poles are actually not the direct rays, they are the slanting rays. So that's why these direct rays which are actually falling on the equator, they are of more concentration compared to those rays which are falling on the poles where the concentration is very less. Okay, so the amount of insolation received in the polar area is comparatively lesser than the amount of insolation received in the equatorial region. But the first statement says that the total amount of insolation received at the equator is roughly 10 times more of that received at the poles. So technically, yes, the equatorial region, it receives more amount of insolation, but it is not up to 10 times. Okay, this is a very higher amount. So this statement is actually a wrong statement. Then if you see option B, infrared rays constitute roughly two-thirds of the insolation. So again, if you see the insolation, the incoming solar radiation, it is a electromagnetic radiation. It consists of different rays of different wavelengths. For example, it has infrared rays, and it has UV rays, and it has visible rays. So the sun's insolation contains all these three types of rays. But what they are saying in option B is infrared rays constitutes roughly two-thirds of the insolation. So one thing you have to notice here. So the amount of infrared rays depends upon one thing, that is, let us say the sun, the temperature of the sun is very high compared to the temperature of the earth. So let us say the temperature or the rays emitted by the sun, it has more temperature compared to the earth's rays. That's why the sun's rays, they are actually short waves of form. If you compare it with the earth rays, it will be of long waves form. So comparatively, the earth's radiation, it has more long waves, that is the infrared waves. So I'll show you the picture, you will understand. Let us say this is the spectrum of the waves, and we have infrared waves here, and we have visible light here, and we have ultraviolet rays here. So as we already saw, the sun's light actually emits all these three type of rays. And if you see, this visible light and the ultraviolet light are of short waves form. These are short waves compared to the infrared waves, which is a long wave. Okay, so technically the sun, which has more temperature compared to the earth, so it will be radiating more of a short waves and some of the long waves. Okay, but in earth's case, the earth radiates the terrestrial radiation, it will be radiating more of a long waves. Okay, the earth's radiation, it has more of a long waves, that is the infrared wave. Okay, now let us go back to this question. So statement B says that infrared rays constitute roughly 2/3 of the insolation. So technically in the insolation, the incoming solar radiation, it contains more of a short wave, that is the visible waves and the UV rays. It also contains infrared rays, but the infrared rays are not, major constituents. They are telling 2/3 of the, you know, 2/3 matlab it is one of the major constituent. But infrared rays, they are not the major constituent in case of a incoming solar radiation. Whether if they are talking about the terrestrial radiation, then yes, the major constituent of the terrestrial radiation would be a infrared rays, okay, because they are long waves, okay. But so this statement is a wrong statement. Then we have statement C: infrared rays or infrared waves are largely absorbed by the water vapor that's concentrated in the lower atmosphere. First of all, if you see here, what they are saying is the infrared waves are largely absorbed by the water vapor. Okay, let us, I'll show you the picture. So yesterday we saw the atmosphere has the greenhouse gases like carbon dioxide and other greenhouse gases. Apart from that, we have water vapor and we have dust particles and aerosols. So what happens is the incoming solar radiation, it passes through the atmosphere, and some of the incoming solar radiation are reflected back or absorbed by the atmosphere itself, and some of them are scattered by the dust particles or aerosols. Only some of the insolation is actually reaching the earth's surface. We saw this yesterday's class, and these insolation, the heat, it heats the surface of the earth, and then the earth starts to radiate back the heat which was received by the solar radiation. And this particular radiation which is emitted back by the earth's surface is actually called as terrestrial radiation. We saw this in yesterday's class in detail, so go back and check that video also. So in case of this terrestrial radiation, we have seen that these greenhouse gases, they are kind of transparent to the incoming solar radiation. Okay, why? Because the incoming solar radiation, it mostly consists of the short waves, that is the visible rays and the ultraviolet rays. So these greenhouse gases or other constituents of the atmosphere, they are kind of transparent to these incoming solar radiation. But this terrestrial radiation, it is of long wave, that is, we can say it consists of infrared waves. So because it consists of this infrared waves, what happens is this infrared waves, okay, once reach the atmosphere, the greenhouse gases or the clouds or the water vapor, what they do is they have a property of absorbing the long waves, that is the infrared waves. So these infrared waves are actually absorbed by the water vapor or the greenhouse gases. But first they absorb it and they re-emit it back to the surface of the earth. Okay, so they'll be absorbing the greenhouse gas, absorbing the infrared waves or the long waves, and they'll be re-radiating it back to the surface of the earth. That's why we saw that the earth's surface increases, you know, because of the greenhouse gases. We read this, we saw this in the previous classes. So go and check that. So with that, what we can say is because of the increase in greenhouse gases, we can say the temperature of the earth also increases. Okay, and this will also cause global warming. Okay, in natural case, this will actually help in maintain the temperature of the earth. It will keep the earth, maintain the earth, making it neither too cold nor too hot. Okay, but in recent years, what happens with the increase in the greenhouse gases and the increase in the amount of carbon dioxide? Because of this particular phenomena is has increased. When there are more number of greenhouse gases, they will be re-emitting the infrared rays or the long rays back, more. Then what will happen? More increase in the temperature of the earth will happen. Okay, this will lead to a increased global warming. Okay, so now in the question what they are saying is infrared waves are largely absorbed by the water vapor. Is that true? Yes, the infrared waves which are radiated back by the earth, they are of long waves form. These are actually absorbed by the water vapor and then re-radiated back, you know, to the surface of the earth, causing the global warming. Yes, this part of the statement is correct. Then the second part says that that is concentrated in the lower atmosphere. So they are saying in the second part of the statement that the water vapor is concentrated in the lower atmosphere. Is that true? Yesterday we saw one of the question where we were talking about, the water vapor, and we already saw this fact that with increasing in altitude, height, the water vapor will be decreasing. What it means? The lower atmosphere, it actually contains the maximum amount of water vapor. Okay, simple. So this part of the second part of the statement is also correct. First part of the statement is also correct. So the correct answer would be option C. And if you see option D, infrared waves are part of visible spectrum of the electromagnetic waves of solar radiation. So just now I showed you that picture, right? I'll show you once again. So if you see here, this is the spectrum of, the waves. And we saw here, this is the visible light, this is the ultraviolet, wave, and this is infrared wave. What they're saying in the option D is these infrared waves, they belong to the visible light. So technically, no, only the visible light, that is visible to the human eyes. Those colors which we are seeing, they are emitting, the light. Those are visible light. But apart from that, the infrared, waves we can't see. It's not visible to human eyes. But what they are saying in option D, they are saying that the infrared waves are part of visible spectrum. No, it does not belong to the visible spectrum because we cannot see the infrared rays in the normal human eyes. Okay, so we can eliminate this option because this is wrong. Correct answer would be option C, that is infrared waves are largely absorbed by the water vapor that is concentrated in the lower atmosphere. Okay, this is the correct answer. Now let us go to the, before that we'll have, the explanation given here. The electromagnetic waves are primary form of solar radiation. So whatever the solar radiation, the incoming solar radiation which we receive, right? This incoming solar radiation primarily, it is of form electromagnetic waves. These are the electromagnetic waves of different wavelengths. From here, these are shorter wavelengths, and when you move towards the side, these are, longer wavelength. So technically the infrared waves have longer wavelength compared to the visible light and the ultraviolet waves. Okay, some of the solar radiation that reaches the earth is absorbed, reflected, and scattered by the atmosphere. Yesterday we saw this, right? When the solar radiation, it tries to, reach the earth's surface, the earth's atmosphere, what it does to the insolation, some of the insolation, they are reflected back. We saw the ice caps and the clouds. So these ice caps and the clouds, they actually reflect back the some of the insolation, incoming solar radiation, and we saw this effect as a albedo effect. Okay, and some of the insolation, they are scattered in all the direction by the dust particles or the aerosols, and some of the incoming solar radiation are absorbed by some of the gases. Okay, this thing we saw yesterday. So what happens is the atmosphere is transparent to the short wave radiation. So what are these short wave radiation? If we saw in this spectrum, right, the visible light and the ultraviolet waves, these are some of the short waves. So these short waves are actually, you know the atmosphere let these short waves through pass to them and to reach the earth's surface. But what happens is it includes the visible light and the ultraviolet radiation. But what happens is the atmosphere is opaque to the long wave radiation. So whenever there is a terrestrial radiation, You know, the terrestrial radiation is of form long waves. Okay, it contains majorly of the infrared waves. So what happens is this atmosphere is actually opaque to the terrestrial radiation, to be specific to the long wave radiation. So what is the long wave radiation? That is the infrared waves. Okay. On the other hand, we saw this. It includes infrared radiation emitted by the Earth's surface. Okay, you understand this, right? Let me explain you here. What they are technically saying is the incoming solar radiation, and let's say this is the atmosphere. So in the incoming solar radiation, the short waves are actually, they pass through the atmosphere and they reach the Earth's surface. Okay, and what these short waves contain? One is visible waves, and other one is UV rays. So these two waves are technically the short waves. So the atmosphere, act transparent to these short waves. Then what happens? After this insolation heats up the Earth's surface, the Earth's surface will radiate back some of the heat. And this is called as terrestrial radiation. And it is of form long waves. And technically, what are these long waves? These are nothing but the infrared rays. Okay. So that's it. So the infrared radiation, often referred to as infrared waves or heat radiation, is a type of electromagnetic radiation with longer wavelengths. Okay. So infrared waves are of longer wavelength compared to the visible light and the ultraviolet radiation. When this infrared radiation interact with the Earth atmosphere, certain gases such as water vapor, carbon dioxide, methane, they have a certain type of molecules. What they will do? They will be able to absorb these infrared radiation. Okay, once they absorb the infrared radiation, then they will re-emit this radiation towards the surface of the Earth. Okay, so these infrared radiation and re-emit this radiation. That's why what happens? That's why this long wave radiation or the terrestrial radiation is not able to escape the atmosphere to the space, and it is re-radiated back to the Earth's surface. Because of that, the Earth's surface and the atmosphere, they both get heated up. Okay, and this will cause the global warming. So these gases are called as greenhouse gases. That's why we yesterday saw this phenomena. So these greenhouse gases, they technically trap the heat in the atmosphere. Okay, just like a greenhouse panels in a greenhouse trap. So what they do is they just trap the heat. They don't let the heat escape the atmosphere to the space. They just trap it just like a blanket over the Earth's atmosphere. Okay. Then, as a result, the infrared radiation absorbed by the water vapor and other greenhouse gases contributes to warming of the lower atmosphere along with the Earth's surface. Okay. This process is essential for maintaining the Earth's temperature. So actually this process is not a bad process. Okay, it actually helps to maintain the temperature of the Earth. Let's say this particular phenomena is not there, then what will happen? Earth will turn into a cold ball. Or let's say this particular phenomena is actually helping the Earth to keep it, neither too cold nor too hot. Okay, but what happens is, because of the human activities such as burning of fossil fuels, okay, like burning of coal and everything, fossil fuels, apart from deforestation, have increased the concentration of greenhouse gases in the atmosphere, leading to enhanced greenhouse effect and the global warming. Okay, because of the human made, increase in the greenhouse gases, especially the carbon dioxide. Because of that, this particular global warming, this phenomena is increasing in recent years. Then, water vapor in particular is abundant in the lower atmosphere. Yesterday we saw this, right? In one question we were talking about this particular point, that the water vapor, it is abundant, or the water vapor is found maximum at the lower atmosphere, and when you move towards, if you increase the height or the altitude, the water vapor will be decreasing with increasing altitude. And we also saw another point. What is that? Let us say this is earth, this is equator, and this is pole. So when you move towards, pole from the equator, then what will happen? You will be seeing a decrease in water vapor. Why? Because the equatorial region, because it gets the maximum insolation, the water vapor present in the atmosphere is maximum. Why? Because when there is maximum insolation, there will be maximum evaporation, right? When there is maximum evaporation, then the water vapor present in that particular location will be maximum. Compared to the poles have a less number of water vapor. To be specific, the equator region, it contains around 4% of water vapor in the atmosphere, and the polar region contains less than 1% of the water vapor in the atmosphere. Okay, so with that we can say that yes, we already saw the answer, right? Then next question, consider the following statements. Statement 1, the soil in the tropical rainforest is rich in nutrients. Statement 2, the high temperature and the moisture of tropical rainforest cause dead organic matter in soil to decompose quickly. So what they are saying is, they are talking about the soil in the tropical rainforest. So in the first statement, they are saying that the tropical rainforest, the soil which are present in the tropical rainforest, they are rich in nutrients. So technically this statement is a wrong statement. Why? Because usually when you see the soil present in the tropical rainforest, they are devoid of nutrients. They are poor in nutrients. Why? Because in rainforest, because of the humid climate and heavy rain, what happens is, one, there will be, the decomposition process will be very fast. So because of that, the nutrients, they don't stay in the soil. That's one reason. Then second reason is, you might have heard that or read that in the tropical rainforest, it almost rains every day, like throughout the year. So when there is continuous rain happening in that particular area in the forest, what will happen? It leaches out the nutrients present in the top layer of the soil. Simple. Okay, it just leaches out the nutrients. So there is no nutrient present in the layer, in the soil layer. Okay, so we can say in the soil which is present in the tropical rainforest, it is actually poor in the nutrients. So this statement is a wrong statement. So if you see, once you eliminate this, first statement, go see for the answer. A says that both statement 1 and statement 2 are correct. So this is, obviously we can eliminate this option. Then both statement 1 and statement 2 are correct. Again, eliminate this option. Why? Statement 1 is wrong. Then C, statement 1 is correct but statement 2 is incorrect. Again, eliminate this option. Why? Because statement 1 is, we found out, which is already a incorrect statement. Then statement option D, statement 1 is incorrect but statement 2 is correct. Yes, directly we get the answer. The answer is option D. Okay, still we'll see what they are saying in the second statement. Second statement, they are saying the high temperature and the moisture of tropical rainforest cause dead organic matter in the soil to decompose quickly. Yes, this is true. As I already told you, there is high temperature, high humidity in the tropical, rainforest, and because of the high moisture, what happens is, these dead organic matter, they just decompose very quickly, and because of this only, what happens, there is, no presence of nutrients in the soil. Okay, so this particular statement is a correct statement. So the tropical rainforest soil is not nutrient rich, it is poor in nutrients. Okay, the nutrients are recycled very quickly by the ecosystem due to rapid decomposition. Okay, and they don't remain in the soil. The nutrients, they don't remain in the soil. This is one reason. And the high volume of rain in the tropical rainforest washes away the nutrients out of the soil more quickly than the in other climates. When you compare it with other climates, this climate is having rainfall throughout the year. It almost rains every day. Okay, though what happens is, these heavy rain, it will wash away the nutrients present in the soil. That's why the soil is devoid of any nutrients. So this is another reason. The soil in the tropical rainforest is not rich in nutrients. Okay. Then next question. Consider the following statements. High clouds primarily reflect solar radiation and cool the surface of the earth. Statement 2. Low clouds have high absorption of infrared radiation emanating from the earth's surface and thus cause a warming effect. So in yesterday's class we were talking about the clouds which actually reflect back the incoming solar radiation and also the terrestrial radiation. Okay, it was in general, but if you see in particular, there are two types of, majorly you can categorize the clouds into the high clouds and the low clouds. Okay, high clouds are the clouds which are present in the higher altitudes, higher heights, and low clouds are some clouds which are present in the lower atmosphere. Okay, so based on the height of the cloud also, there is a difference, how they reflect back the radiation or absorb the radiation. So these things also vary. So technically we were talking about the clouds in general yesterday, but we'll be seeing in detail about how the high clouds and the low clouds they behave for the radiations, the incoming radiation and the outgoing radiation. So before answering this question, let us have a look at, what are the things related to the high cloud and the low cloud. So this is the high cloud you can see here, and this is a low cloud. So high clouds are present in the higher atmosphere and the low clouds are present in the lower atmosphere. Simple. So first, in case of an incoming solar radiation, what happens is these high clouds are very thin. Okay, they are not very thicker. So because of that, what happens is these incoming solar radiation, very small amount of incoming solar radiation are reflected back by the high clouds. Okay, so majority of the incoming solar radiation passes through the high cloud and they actually reach the earth's surface. Okay, this is the first point. Then in case of a low cloud, these low clouds are thicker compared to the high clouds. These clouds are usually, thicker. That's why they are present in the lower atmosphere. So because they are very thicker, what happens is majority of the incoming solar radiation gets reflected back to the space. Okay, so this is the first point, the difference between a high cloud and the low cloud in case of an incoming solar radiation. Okay, now in case of a terrestrial radiation, what happens is, in case of a terrestrial radiation, these high clouds, what they do is, yes, they let some of the, you know, terrestrial radiation to escape to the space. But what happens is they also, are responsible to the trapping of the heat. What these high clouds do is they absorb the terrestrial radiation, the long wave radiation, and they re-emit the radiation towards the earth's surface. Because of that, the surface of the earth along with the lower atmosphere, they get heated up, because of this radiation. But what happens in case of a low cloud is these terrestrial radiation, most of the terrestrial radiation, it lets to, escape to the space. Okay, but only some of the terrestrial radiation will be, trapped by the low clouds. Okay, now let us go back to this question. First statement says that high clouds primarily reflect solar radiation and cool the surface of the earth. Is that so? See here, they are saying primarily reflects the incoming solar radiation and it cools the surface of earth. No, that's not happening here. It is not primarily letting the incoming solar radiation, it is not reflecting. It is actually letting them pass through. Majority of the incoming solar radiation, the high clouds are letting them to pass through and reach the earth's surface. Because of that, the temperature of the earth's surface is, warm, not cold. So we can say this particular statement is a wrong statement. Now statement 2 says that low clouds have high absorption of infrared radiation emanating from the earth's surface and thus cause a warming effect. Just like we saw in the previous question, yes, clouds, what they do? we saw different, greenhouse gases, water vapor, and clouds also. What they do is, yes, they actually observe the incoming, not the outgoing terrestrial radiation, and after absorption, what they do, they re-emit this particular radiation back to the surface of the earth. We read this, okay, but here in the second statement, what they are saying is the low clouds. They are talking about the low clouds here, and they are saying the low clouds have high absorption of this terrestrial radiation. Infrared radiation matlab, it's nothing but the terrestrial radiation. Either if they say infrared radiation, or if they say long wave radiation, or terrestrial radiation, all these are same only. Okay, so they are saying in case of an terrestrial radiation, the low clouds, they actually have high absorption. When they have high absorption, what they will do, they'll re-emit to the earth's surface, which will increase the earth's temperature. But we saw this in this picture. See here, most of the infrared waves are actually pass through it. Let this low clouds, they let them go. They let the long wave radiation to escape to the space. Okay, only few of the infrared radiation, they are trapped by the, or absorbed and re-emitted by the low clouds. This thing is actually related to the second statement, is actually related to the high clouds. How? If you see here, majority of the infrared rays, that is the terrestrial radiation, they get reflected back, or you can see absorbed and re-emitted back by the high clouds. So again, this particular statement, second statement, is also a wrong statement. So answer is D, neither one nor two. So if you see here, the high clouds are often thin and do not reflect very much. Okay, because the high clouds are very thin compared to the low clouds, they do not reflect much of a incoming solar radiation. And the low clouds are often quite thick when compared to the high clouds. The low clouds are very thick in nature. Because of that, they reflect back most of the incoming solar radiation. And the main difference between high cloud and the low cloud is that the high clouds are colder. So the clouds which are present in a higher altitude, they are much colder compared to the clouds which are present in the lower altitude. So because of that, what happens is they radiate less energy into the space than the warmer clouds, and therefore the high clouds work to trap more of the energy than the low clouds. The high clouds are not good at reflecting short waves. Okay, short waves are nothing but the incoming solar waves, and but they are very good at blocking the long waves. So what they are technically doing is, these high clouds are like they are letting the incoming solar radiation to pass through them and reach the earth's surface. So this is actually increasing the earth's temperature. Along with that, what they are doing is, they are good at trapping the long wave radiation, that is the terrestrial radiation. So these high clouds are actually trapping the long wave radiation, that is the terrestrial radiation. So again, it is inducing, it is increasing the earth's temperature. So in both the cases, both allowing the incoming solar radiation, and it is also trapping the outgoing terrestrial radiation. So because of both of this activities done by the high clouds, the high clouds are directly involved in increasing the temperature of the earth's surface. This also traps heat, thus the high clouds will cause warming of the earth's surface. Okay, but in case of a low clouds, what they are doing is, first, they are excellent reflectors. First of all, they are reflecting majority of the incoming solar radiation, so they will help in cool down of the earth's surface. Okay, first point. Then they don't stop the long wave radiation from escaping the space. Again, what they are doing, in case of a long wave radiation, that is the terrestrial radiation, they let the terrestrial radiation to escape to the space. Okay, so therefore the low clouds are actually, they're not increasing the earth's temperature, they're actually cooling down the earth's temperature. Next question, the vegetation of savanna Consist of grassland with scattered small trees, but extensive areas have no trees. The forest development in such areas is generally kept in check by one or more or a combination of some conditions. Which of the following are such conditions? 1. Burrowing animal and termites. 2. Fire. 3. Grazing herbivorous. 4. Seasonal rainfall. And 5. Soil property. So they are talking about the savanna. Savanna are the grasslands, okay? So technically what they are saying is, in the savanna grasslands, which of these following, given options, they actually keep a check of the vegetation, or you can say they will impact the vegetation or the forest development, okay? Which of these following impact the development of the forest in the grasslands, okay? So if you see, first they are saying burrowing animals and termites. Actually maybe this burrowing animals and termites are actually one of a reason, but these are not very significant reason, okay? These are present, yes, it is present in this type of climate, but it is not significant, and it does not keep check in the development of the these type of forest. So we can eliminate this option. And if you see fire, yes, in case of a fire, it actually keeps check in the development of the these type of forest. How? Let us say these savanna grasslands, these are of type, these are alternate wet and dry climate, which means there will be, sudden rain also, then they'll be having complete dryness also. So in times of dryness, complete dryness, what will happen, these grasslands, it is prone to the fire, forest fire, okay? So yes, when there is a forest fire, it will actually hamper the development of this particular forest type. So forest fire is there. Then grazing herbivores, as we see this type of forest is a grassland forest, okay? So because it is a grassland, it will be having majority herbivorous, that is, these are the grazing herbivorous. Let us say there are more number of grazing herbivorous, and they are keep on grazing. What will happen then? They literally consume all the seeds and everything, okay? Because of that, it will actually keep the check in development of the forest in this particular area. So yes, this is also there. Then it has seasonal rainfall. Yes, as I already told you, this type of climate is wet and dry climate, alternate wet and dry climate. So this type of climate actually has very seasonal type of a climate, similar to monsoonal type of climate. Let us say in monsoonal type of climate, we'll be having rain in a particular season. Just like that, in this areas of savanna grassland, we'll be having rain in any particular time of year. But if you see, it is different from the monsoonal time of type of climate. How? Because let us say in monsoonal type of climate, during a particular period of a year, there will be rain, but in this case there is no guarantee that or the rain will be happening in any particular period of time, okay? It will happen uh, very irregularly, okay? So this is there. Then we have soil properties. Again, soil properties, these may have some impact on the development of the forest, but this is not a major, it does not create any major checks on the development of the forest. Why? Because usually if you see these type of, in this type of climate, the soil is very rich in nutrients, not very, but comparatively it has some nutrients to grow the forest, okay? So the soil properties does not actually impact the development of the forest in very significant way, okay? So that's why we can eliminate this option. So what would be the correct answer? The answer is 2, 3, 4. Option C is the correct answer. So if you see the savanna grasslands, they are tropical wet and dry climate, or Sudan climate. They are also called as Sudan type of climate. This type of climate has alternate wet and dry seasons, similar to the monsoon climate, but has considerably less annual rainfall. Okay, just like the monsoonal type of climate, these type of climate, that is a Sudan type of climate or wet and dry type of climate, they'll also be having very seasonal rainfall. But in case of a monsoonal type of climate, a particular season rain will come. But in this case, there is no guarantee. The rain is very irregular, and also the annual rainfall, if you calculate, it is very low compared to the monsoonal type of climate. Also, there is no distinct rainy season like the monsoon climate. As I already told you, in monsoonal type of climate, there is a particular time period from June to September, like that. But in case of a, this type of climate, Sudan type of climate, there is no particular season. It can rain very irregularly whenever it want. Okay. Then there are only two seasons here in this type of a climate. We have only summer and we have only winter, and it rains during the summer, climate, summer period, then summer season. Okay. Floods and droughts are common. Again, let us say during the summer when it is having high rain, suddenly it will be having floods. At the same time, when there is no rain, it will have droughts also. So both flood and droughts are common in this type of climate. Okay. So when there is a drought, when there is a dry type of season is happening, there is no rain, then these grasses, what will happen? These grasses dries out and they are prone to the forest fires. Okay. The savanna landscape is typified by tall grasses and short trees. So these grasslands, they actually have uh, tall grasses. The grasses are very tall and the trees are shorter compared to other type of climate. And the vegetation depends on grazing intensity. What is grazing intensity? Let's say these herbivores, they have they consume the grasses. Okay, because they are herbivores. So what happens is when there is high number of herbivores, big herbivores, they'll be consuming fast, very fast, they'll be consuming all the grasses, and this will also lead to the you know um, underdevelopment of the forest. Okay. And when they are grazing these grasses, along with the grasses, they may also consume the seedlings. Okay. When these seedlings are consumed by the herbivores, the seedlings are not left for again the production of the grasses. So that is also one reason. And it is not burrowing animals or termites. Even though this is one of the factor is there, but it's not a very significant factor. Okay. Then fire. So frequent fires, they are prone to frequent fires. Why? Because um, as we already saw during the dry season, these grasses, they get dries up and they are prone to the forest fires. Okay. And during the fire, what happens? These seedlings, they also get burnt out, and there is no seedling left for the production of forest again. So that is one reason. And grazing herbivores, we already saw this point. Then seasonal rainfall. So these savanna, type of grassland, they'll be having seasonal rainfall. We already saw all these, factors. Then next question, leaf litter decomposes faster than in any other biome, and as a result, the soil surface is often almost bare. Apart from the trees, the vegetation is largely composed of plant forms that reach up to the canopy vicariously by climbing the trees or growing as epiphytes rooted on the upper branches of the trees. This is the most likely description of coniferous forest, dry deciduous forest, mangrove forest, tropical rainforest. So they have given a description of a particular type of forest, and they are asking which particular type of forest has this particular description. If you see, this type of question, comes again and again, often, in every, mostly, almost every time, and they literally give some description of any particular type of climate or any particular type of forest, and they'll be asking which of these have this description. Okay. So if you see here, the leaf litter decomposes faster than any other climate. Just now we saw in one of the previous question in this particular video that the leaf litter or the organic matter, the dead organic matter, it decomposes very fast. We saw this particular property right now in one of the question. And this is a property of which forest? Tell me the answer. The answer is tropical rainforest. So in tropical rainforest, we saw that because of heavy decomposition, the decomposition is very faster, because of the humid climate and the heavy rainfall. There is the nutrients in the soil is very poor. That's what we saw, right? So this first point, heavy litter recompose faster than any other biome. So this is one of the description given to the tropical rainforest. And if you see, because of that, the soil surface is almost bare. Yes. And other reason is there is heavy rain. Because of that, the leaching of the surface of the soil, it leaches out the top surface of the soil along with the nutrients. That's why it is very bare. Apart from trees, the vegetation is largely composed of plant forms, and they are especially talking about the climbing of these particular plants as epiphytes. So if you see here in this picture, you can able to understand. This is the picture of a tropical rainforest. You will be having different layers of trees, different canopies you can see. And apart from that, what you can see, these are epiphytes. These plants, these type of plants, they grow around the trees. Okay, by spiraling around the trees, and it will reach up to the top canopy. Also from the ground they'll be crawling, and these are climbers, they are also called as climbers. They'll be crawling and climbing up to the top canopy. And if you see this Tarzan, he'll be like you know swinging from one tree to another tree by the use of these epiphytes. These are epiphytes. Okay, so it is present in the tropical rainforest. You can see that in this picture. So these are the epiphytes. Okay, these are the epiphytes. So tropical rainforests are categorized by their dense vegetation. So usually the tropical rainforest, they'll be having a very dense vegetation. We saw in this particular picture, right? And high biodiversity. Okay. Leaf litter in this forest decompose rapidly. So whichever the leaf, they fall on the soil, they get decomposed very fast, very rapidly. That's why there is no presence of nutrients in this particular soil. And why this is happening, why the decomposition is happening very fast? Because of the warm temperature, because the tropical region, it is present in the tropical region. Obviously it is getting more sunlight compared to other areas, so it is having a warm temperature. Then high humidity, as we know that in tropical area, the equatorial area and the tropical area, what happens? Because of high insolation, high amount of evaporation takes place. And because of high amount of evaporation, the formation of cloud and the precipitation will be very high. So this equatorial region and the tropical region, they get high amount of rainfall, and they'll also cause the high humidity. So high temperature, high humidity and high rainfall, all these factors together, what they do, they help in decomposition of the dead matter very fast, okay, very rapidly. And this fast decomposition leaves the soil surface bare. Okay, and there is another reason. What is that reason? Because of heavy rainfall, it leaches out the nutrients present in the soil. Besides towering trees in the canopy, the vegetation is diverse and complex. See here, these are towering trees. They reach high, the high heights, and different layers of canopy. You can see different layers of the trees. Along with them, there are also these, climbers. And many plants, what they do, they utilize these trees for a support, and either by climbing them or by growing as epiphytes on their branches. Okay, there are two types. Let us say this is a tree and this is another tree. So either from the from the soil, some plant, some climber, they'll be taking support of this tree and they'll be reaching the height. Okay, then there is another category, that is the epiphytes, from the branches of the trees. And technically this Tarzan guy, he'll be using the epiphytes to jump from one tree to the another tree. These climbing plants, they reach up to the canopy by twining around the tree trunks or using specialized structure like tendrils. Epiphytes such as orchids and ferns grow on the tree branches, drawing nutrients and water from the air and the rainfall. This unique vertical stratification allows for efficient use of available light and resources, contributing to incredible biodiversity and structural complexity of the tropical rainforest. So, whenever they talk about this vertical stratification, it is directly related to the tropical rainforest. Okay, see here, this vertical stratification, each layer it is having different type of trees and plants. Okay, because of this vertical stratification, what happens is each type of plant or each type of trees, they are efficiently using the resources, and because of this there is a very diverse nature of diversity present in this type of rainforest. Okay, so with that we have completed today's class. We'll be seeing in the next class, we'll be continuing the topic climatology, and we'll try and complete this particular topic. Okay, thank you students.